Good morning, good afternoon, good evening, everyone. So thank you very much for your time today and joining this webinar, Getting Started with ConsenSys Quorum, a technical look at GoQuorum and Hyperledger Besu. So it's an honor to have you with us today. So maybe before we start, just a quick recap. So this summer, as you have probably heard, ConsenSys acquired Quorum, the Ethereum client from JP Morgan. So this is part of a multifaceted partnership between ConsenSys and JPM. So it did have an impact on the branding of our product offering. So basically, when we introduced the Quorum brand in ConsenSys, we decided to use this brand as an umbrella brand for all our open source offering. So including in particular Hyperledger Besu, so our historical Ethereum client that we have been building with the Pegasus team, which is now the protocol team in ConsenSys, and the second Ethereum client that we got from JPM, GoQuorum. So basically, when we say GoQuorum, it's to refer to the Enterprise Ethereum client software and to make the distinction between this software and Quorum, which is now the umbrella brand over all our open source offering. So let's go. So just some friendly reminders. So please stay mute during all this session. Please ask your question by submitting it in the Q&A box. So please feel free to ask as many questions as possible. We have Grace with us today, who will be tracking all the questions, and she will be able to raise it to us during the presentation. And about the content of this presentation, so everything will be shared with you, including the recording of this webinar and the slide decks that we are presenting. So today we will be 4 speakers. So starting with myself, Nicolas Maurice. I am based in Paris. I am the technical lead for GoQuorum at ConsenSys. I have been with ConsenSys for the past 3 years. And I just moved to this new position since we acquired Quorum in ConsenSys. So my main responsibilities will be to create and lead the team that will be maintaining GoQuorum on the long term. Madeline, would you like to introduce yourself?
Sure, thanks, Nico. So I'm Madeline, I'm the protocols product lead at ConsenSys. The protocols team builds ConsenSys Quorum, which we're talking about today. As well as Quorum, we also build our ETH2 client Teku, privacy and signing components, and orchestrate a transaction orchestration system. Really excited to be talking to you today about the work we're doing to make GoQuorum interoperable with Hyperledger Besu and ensure we've got the best of both clients. We're customer focused, so as always, if you've got any feedback, roadmap requests, reach out to any of us. Our emails are on the slide above. You'll also find us in our community channels, so that's Rocket Chat for Hyperledger Besu, ConsenSys Discord, or the GoQuorum Slack. And over to Ben.
Hey everyone, I'm Ben Burns. I'm based in Christchurch, New Zealand. I'm a tooling and infrastructure engineer with ConsenSys Quorum, along with everybody else. And yeah, I'll be giving a demo today of our Quickstart tool to show you guys how you can get up and running really quickly with a ConsenSys Quorum blockchain of your choosing on your own laptop or workstation. Over to you, Josh.
Thanks, Ben. So I'm Josh Fernandez. I'm based in Brisbane, Australia. And Ben and myself, we look after a lot of the DevOps and infra and tooling kind of aspects. Things like architecture, networking, how things work and drop, all those sorts of things. We would love to hear back from you if we can help in any way. Back to you, Nicola.
Thanks a lot. So the agenda for today. So first, we will try to remind you what is an Enterprise Ethereum client. Then we will be discussing the roadmap of Hyperledger Besu and GoQuorum, and try to compare the different features that both those clients are offering. So in which way they are compatible, on which way we will be working on aligning them to be more interoperable. And then Ben and Josh will give us a demo of our Quorum Quickstart. So hopefully it will give you the will to use it and play with Hyperledger Besu and Quorum, and then we will keep time in the end for a Q&A session. So first, what is an Ethereum client? So an Ethereum client is the software that implements the Ethereum protocol and that is run by a blockchain node to connect and take part to an Ethereum blockchain network. So it's basically the software that allows multiple nodes in the blockchain network to share a ledger of transaction, which is maintained in a decentralized fashion. And I will not be diving into what exactly a blockchain is, but I'm pretty sure that everyone knows it today. But maybe what is less clear for people is what is actually contained in an Ethereum client, and so I will be listing the main components of a client. So the first main component that we find in an Ethereum client is the peer-to-peer networking layer. So it's basically the layer that allows the nodes in a network to communicate information in a peer-to-peer fashion. And in particular, the type of information that are sharing are the blocks. So typically, every time a validator node mines a new block, it will be transmitted to the other nodes through this networking layer. All the transactions are also spread over the network through the peer-to-peer layer. So when a user sends a transaction to a node, this transaction will be then transmitted to the other nodes through the peer-to-peer layer. And there may be some other messages depending on the cases, in particular for the consensus engine to achieve their work. Typically, the IBFT consensus uses some extra messages to communicate information in order to achieve the consensus over the new blocks. So this peer-to-peer networking layer is based on the DevP2P protocol. So all the Ethereum clients implement this component, which is one of the most important components of the client. The second major component is the consensus engine. So it's basically the piece that allows the node in the network to reach consensus over the blocks to be added in the ledger. So there is one consensus engine per type of consensus algorithm. So there will be one for proof of work, there will be one for proof of authority click, etc. And each of those consensus engine implements a set of rules in order for the node to validate if block matches the expectations and the constraints and the rules of a given consensus algorithm. The third main piece is the Ethereum virtual machine, or the EVM. So this is the execution environment for processing transactions. So in particular, to execute the smart contracts. So it's the runtime of our blockchain, and it allows to execute the code of our smart contract. And when we are executing this code, we are able to interact and interface with the underlying storage of the blockchain node, so to modify the storage. So which leads me to the first component, which is the database and the storage that allows to persist the data in a blockchain client. So this data includes the ledger data, so the blocks, the transactions, the receipts, and also all the state data. So in particular, the balances of the accounts, the smart contract state, etc. And so this state data is what is basically being modified by the transactions being executed by the EVM. And finally, the last main component are the APIs, so which allows applications or clients to interact with the blockchain. So the main one is the JSON RPC API. So this is the API that allows you to send transactions. It will also allow you to read data from the storage, if there is ledger data or smart contract state data or any other information. So there is a quite extensive list of JSON RPC methods available in a client. And then the second type of APIs that we have that are now almost a standard for every Ethereum client are the GraphQL APIs. Which are APIs which are optimized to query information from the ledger data. So it's much more to view information from the ledger. So now, this was for the introduction of an Ethereum client, and now what we will try to detail what we name an Enterprise Ethereum client. So an Enterprise Ethereum client is an Ethereum client that implements some extra features or modules to enable Ethereum sub-protocols that fit some enterprise use cases. So the first feature that we have been adding with Enterprise Ethereum is permissioning, which basically allows to restrict the access to a network. We distinguish two flavors of permissioning. So the first one is the node permissioning, which is basically to restrict the peer-to-peer network access to only a set of allowed nodes. So this is typically when you are on the public mainnet, any node can connect to the network. In some private networks, you want to restrict the access to the network only to a subset of nodes that have been allowed to access this network. So you will be using node permissioning to achieve that. The second flavor is the account permissioning, which is this time applied to restrict the transactions to some accounts. So when saying some accounts is what accounts are allowed to send transactions to which account, and we actually have some more fine-grained rules. So typically, which account can send what type of transaction to which other account, etc. So this can be quite, it could be an authorization restriction, which are quite fine-grained. The second main feature is the privacy. So privacy is the ability to send transactions containing some private information, which is only known by a subset of nodes on the network. So that's typically where the private transactions manager, Orion and Tessera, will be very useful. The third features are around consensus algorithm. So typically, so we have implemented the BFT algorithms, which are meant for faster finality and to increase the performances in terms of TPS, so transactions per second. And finally, the plugins. So the plugins are add-ons or extensions to an Ethereum client, and that enable users to customize their node without having to tamper with the code base of the Ethereum client itself. So we have, so the typical plugins that we are seeing currently are around key storage, around monitoring. Besu has a plugin for event streaming, allowing to push the events into Apache Kafka. And so what we expect is to see more and more of this type of plugins being implemented in the future. So this is a way for users to basically implement some custom feature of interest without having to modify the blockchain client itself. So about Hyperledger Besu and GoQuorum, so both are enterprise Ethereum clients. About Hyperledger Besu, it is the most reliable Java Ethereum client for mainnet and private networks. And GoQuorum is the most used Ethereum client in production permission networks. So going through the features of both those clients. So first, in terms of language, so Hyperledger Besu is written in Java, while GoQuorum is written in Golang. In terms of licensing model, Hyperledger Besu, it's Apache 2, and GoQuorum is GPL. So as you know, GoQuorum is a fork of Guess. Guess is GPL, and so GoQuorum inherited from this license. So both are open source license, but they're not having the same types of restrictions. Then we have, so in terms of features, both Hyperledger Besu and GoQuorum implement a permissioning model. Both implement a privacy model, Hyperledger Besu with Orion, GoQuorum with Tessera. In terms of consensus algorithms, so both have an implementation of POA click. Both have a version of IBFT. GoQuorum implements the rough consensus algorithm, while Besu doesn't. Besu is mainnet compatible, while GoQuorum is not. Then both offer mechanisms for plugins. Both are compatible with EdSigner. So EdSigner is a private key manager that we are building with the protocol team in ConsenSys. Both have a private transaction manager, Orion for Besu, Tessera for GoQuorum. Besu proposes the event streaming. And finally, in terms of support, we provide with ConsenSys the exact same type of support for both Hyperledger Besu and GoQuorum. And so now we will be discussing the roadmap and going through in more details in the feature comparison. And so now I will give the mic to Madeleine.
Thanks, Nico. So this view of the roadmap focuses on the aspects related to interoperability. If you've been to previous webinars, you may have seen a roadmap with more features on it. And if you want to go through the complete roadmap, the recording of the previous webinar is available for anyone that didn't attend. We're really excited about this roadmap because having both clients under one roof enables us to focus on ensuring we take the best of both clients and bring GoQuorum interoperable with Hyperledger Besu. Having ConsenSys Quorum means Quorum users have access to the huge Quorum community, all the innovation of that community, and optionality for the future. We've worked closely with JPM to ensure we find the synergies between the clients and ensure that existing GoQuorum networks have all the functionality they need. We'll be going through these in more detail on the following slides, so I won't dive too deep here, but just to put it in the context and the timeframes. So 2020 Q4, that's where we are now. So we're currently working on permissioning interop, and we're going to be doing our first release of our Quorum bundle. So there's a lot of underlying work happening there. So then moving into next year, so in Q1, we'll have a BFT consensus mechanism that's interoperable. Nico mentioned currently both clients have BFT consensus mechanisms, so this is about ensuring we've got a common mechanism and we can use both clients on the same network with that mechanism. Privacy interop is about ensuring we've got a common privacy model across both clients. Q2 2021, integrated key management. This is about ensuring we've got a common approach to keeping transaction signing keys and validator keys safe in both clients. In Q3, we'll be looking to do some optimizations to the interoperable BFT consensus mechanism and creating a common plugin framework. So that'll allow the same set of plugins to be used across both clients. Then looking further into the future, Active Directory LDAP integration. And another really exciting piece coming in the future is the Interledger integration. So this is about allowing communications and transactions between different Quorum networks initially, and then we'll be looking at Quorum networks and other enterprise blockchain networks. If you could go on to the next slide.
Yes, so now we'll be diving into some of those features to detail a bit how they are comparing and what work we will be leading in the next months and quarters to drive this roadmap through something which is so bringing both clients to be interoperable. Madeline.
Yes, the first piece as I mentioned, we're working on this right now, is bringing permissioning into alignment. So between GoQuorum and Besu, the permissioning models are actually already fairly similar. So both of them have node permissioning and account permissioning managed using smart contracts. So node permissioning is about limiting the participants that can join a network, and account permissioning is about limiting the participants that can either send a transaction or the types of transactions they can send. So because they're both smart contract based, the underlying mechanism to update the permissioning lists is submitting transactions to update the smart contracts. So what we need to bring into alignment to ensure we've got them interoperable is the smart contracts they use currently implement slightly different permissioning models, and the admin management. Currently with Besu, we've got a DApp that you can use to submit the transactions, and GoQuorum has specific JSON RPC APIs. So once we've completed this alignment work, both clients will have permissioning interfaces that conform with the Enterprise Ethereum Alliance technical specification, and they'll have a common approach to updating the permissioning contracts. Thanks, Nico. So a bigger piece of work, and one that we're starting on now and will continue through into Q1 2021, is bringing our privacy models into alignment. So first I'm going to talk about the things that are similar, and then the pieces of work we need to do to ensure we can have private transactions across both clients. So what's similar? They both use private transaction managers, as we mentioned earlier. So the private transaction manager is the piece that distributes the encrypted private transaction payload point to point to the participants of the transaction. Besu currently uses Orion to do this. GoQuorum uses Tessera. Both of these private transaction managers are Apache 2 licensed and written in Java. So the first thing we're going to do is we're going to converge on one private transaction manager, which will be Tessera. We'll be doing the work to ensure that Hyperledger Besu works well with Tessera. So both clients currently have a mechanism through which you can add additional participants to a private contract. In Besu, the past transactions are pushed to a new participant, enabling them to execute and have the historical state. In GoQuorum, late joiners are pushed the current state at the time of joining and not previous transactions. So we'll be aligning on a model there that works for both clients. We'll be ensuring that the same encryption curves are used so they can understand each other's private transactions. And if you've used either GoQuorum private transactions or Hyperledger Besu private transactions, you'll be aware that they use a privacy marker transaction. So a privacy marker transaction is the transaction that goes onto the public chain, and the client needs to have an indicator basically that the client knows it's a private transaction, which triggers the client to retrieve the private transaction payload from the private transaction manager and execute it. So in GoQuorum, a private transaction is indicated by changing the V field in the transaction signature to 37 or 38. This is different to the core Ethereum protocol where the V field is set to 27 or 28. So when GoQuorum comes to a transaction with the altered transaction signature, it triggers the private transaction retrieval and execution. So Besu uses a very similar construct, but instead to trigger the private transaction retrieval and execution, Besu uses a privacy pre-compiled contract. The privacy marker transaction is addressed to the privacy pre-compile, and that's what triggers Hyperledger Besu to retrieve the private transaction and it then can execute it in the private state. Precompiles are part of the core Ethereum protocol, and Besu simply adds an additional precompile to implement this privacy model. So in both cases, when a node that is not part of the private transaction comes to one of these transactions, that indicates it's a private transaction. If they don't have access to the private transaction, as in it's not in the private transaction manager, it'll simply try and retrieve it. It won't be there. It'll carry on processing and there'll be no state changes. And that's it for privacy.
So then the next feature that we are looking to make interoperable is around consensus mechanisms. So first, as of today, GoQuorum and Besu can already interoperate, but on a click POA network algorithm. And so our target is to have them interoperating on IBFT as well. So the current state is that they both have an implementation of an IBFT consensus algorithm. So as already mentioned, here we are aiming for fast finality of transaction and increased performances of the clients in terms of TPS. So they both already have an implementation, but those two implementations are not yet interoperable. So in particular, they differ on some aspects. The block headers used are slightly different, and also the communication subprotocol that they are using to message information relative to the consensus are different. So we need to work to make those elements align and be able to create networks, which are mixed between Besu and GoQuorum clients, and that can interoperate on a single IBFT algorithm. So our timeline to reach that is mid-2021. And finally, plugins. So both Besu and GoQuorum implement the plugin mechanism, so to allow to extend a blockchain client with custom features without having to modify the Ethereum client software itself. So they both have a mechanism for that, but it's still a bit different. So in terms of stack, so Besu plugins are Java-based, while GoQuorum plugins are based on HashiCorp plugins, which may be implemented in any programming language. In the fact, there are a lot of libraries written in Go, which make it probably more convenient to be implemented in Go, but theoretically, it can be implemented in any programming language. And then in terms of architecture, it's also a bit different, since the plugin with Besu run as part of the main Besu process. So basically, when you want to add plugins to Besu, plugins come as some individual Java executables, so the jars. And when you configure your Besu client at runtime, you indicate where those plugin jars are stored, and Besu will automatically load it and start it as part of the main process. While on GoQuorum, it's a bit different. The plugins run in dedicated processes separated from the main GoQuorum process, and they communicate over a secure connection. So it's a mutually authenticated connection using gRPC interface to communicate. So somehow we can see it as the plugin being some kind of server running close to the GoQuorum client, and the GoQuorum client inside as a client to interface and communicate with this plugin server. So what we will be working on is designing and finding and defining an approach that would allow to have both Besu and GoQuorum using the same type of plugins. So basically, to not have to double the work each time we will have to create a new plugin. And so our target is to have it designed for mid-2021. And so now I will give the floor to Ben and Josh that will introduce us to the Quorum Quickstart. So Ben, Josh, your turn.
Hey, great, thanks for that. Yeah, so we're going to go ahead and just give a quick demo of the Quickstart, as Nicola just said. So if you're following along with us, in order to run this, you're going to need a few things installed in your machine already. So you'll want to have a later version of Node.js installed. It needs to be the LTS maintenance release or later, so that'd be Node v10 plus. You'll also want to have Docker and Docker Compose installed. So yeah, that's what this slide is showing here. And if you want to do this later on, actually, if you don't mind, I'll share my screen now. But you can visit this website. The host has just disabled participant screen sharing. I think, Grace, you might need to help me out here.
Yep, 1 sec, sorry, Ben.
Yeah, no worries. There we are. Cool. So you want to make sure, if you want to follow along after this, to visit this page. It's consensus.net/quorum/developers. And just to show you around this page real quick, you'll notice if you click this Get Started button, you'll see the same exact info that we just had on the screen on that slide. So this is just another place you can find it. You can also find on this page, if you scroll down a bit, links to our documentation for Besu, Orion, EthSigner, GoQuorum, and Tessera. So those docs links are down here below these boxes. So to go ahead and get started, you'll notice if you click this, there's a command here to run. It's npx quorum dev quickstart. So I'll go ahead and run that now. And what this is going to do is it's going to pull down a little helper script that we have, and it's going to ask you some questions about what type of blockchain network you'd like to run. Again, the goal of this is just to get you up and running with a simple development-ready network on your own machine. So yeah, so we're going to show off the GoQuorum capability today. So you'll notice we've got this banner here. It says, which Ethereum client would you like to run? By default, it'll say Hyperledger Besu, but I'll show off GoQuorum. And for this demo, I'm going to say no to this. This is asking if we want to try out Codify Orchestrate. I definitely recommend taking a look at this. Orchestrate's a great tool for managing signing of your transactions and ordering of your transactions for like nonce management and things like that. It also handles things like queuing transactions if you need to take a node down to update it and things like that. But I'll say no for now. There's a login and registration required for that. And then finally, it's asking if we want to enable support for private transactions, so I'll say yes. And yeah, it's going to ask where does it want me to let it create the config files for this network, and I'll use the default location, which is just going to create it in Quorum test network. And finally, you can see it says to start your network, run run.sh in the installation directory, which was Quorum test network. So if I cd into Quorum test network, and I have a look in here. Let me just make this a little bit bigger so it's easier to see. In this directory, you'll notice I have a run.sh, a stop.sh, remove, resume, list, so on and so forth. Those are all helper tools like you'd imagine. If you run run.sh, it's gonna spin up the network. Stop is gonna tear it down. Remove will clean everything up for you. But also there's a handy readme. So I'll just show that real quick. So there's a readme.md file. And this kind of walks you through how to use the network that you've just created on your machine if you need some getting started tips. And there's also a nice tutorial in here for running a smart contract, which I'll show you. So let's go ahead and start the network. What? Oh, run, sorry. Sure. So what this is going to do is it's actually using Docker Compose behind the scenes, which is handy because this will automatically pull down all of the Docker images and whatnot that it's going to use for the network. So this is going to be a 4 validator node network with 2, if I remember right, 2 additional participants, private participants. So there'll be a total of if I remember correctly, 5 nodes running. I'll verify that. I'll show you how to verify that in just a second. So while this is going, I was told that I need to tell jokes. So how do you catch a unique animal? Unique up on it, huh? Sorry, it's horrible. How do you catch a tame one? Tame way, unique up on it, huh? All right, sorry. Great, now that we're done, we can get rid of that painful process. Yeah, so you can see it's giving us a list of different endpoints we can reach out to. So for your smart contract, or your dApps, I mean, sorry, you can use this HTTP JSON RPC endpoint here, localhost 8545. The WebSocket port for the same RPC interface is 8546. Also, we have a Block Explorer running and CakeShop. So I'll go ahead and show CakeShop first. I think CakeShop's a great tool for visualizing what's happening on the blockchain. So you notice CakeShop is localhost 8999. So if I go there, so you can see straight away we have three blocks already on the network. The node that I'm talking to, which is validator 1 here, has 8 peers. You can see info about the node, like the node's ID, the enode, the RPC URL for that specific node. But what's nice is you can also go in here to this dropdown and you can connect to any of the other nodes. So actually there are three private member nodes. So if I want to connect to one of those, I switch over here and you can see from this node's point of view, because remember this is a decentralized network, right? So every node has its own kind of picture of the network. From this node's point of view, we have now 10 blocks. And yeah, we can see the number of blocks per minute, transactions per minute, so on and so forth. There's also a nice little chain explorer here. So you can validate, like, you know, member ID, member 1 here for block 11 has this block ID. If I wanted to go in and check that same block ID for one of the other ones, of course, for block 11, I would see the same thing because our consensus algorithm's working and these are finalized blocks. So next thing I'll show is just running a simple private smart contract. So in this Quorum test network directory, we have this smart contracts directory. If I cd into that, you'll notice there's a package.json, so that means it's a Node.js project. So first thing to do is just run npm install. I'll spare you the horrible jokes this time while it loads, because I think this one's pretty quick if I remember right. Hooray, cool. So next thing is we have under the scripts directory a compile.js and a deploy.js. Really, the deploy.js is the one that you want to run. If I take a look at that, I'm not going to kind of go through line by line or anything, but this is a nice example of how to use Web3.js to to create an instance of a private contract and then send a transaction to that. So if you just kind of read through the different functions in here, you know, we've got, let's see, there's a deploy contract in here somewhere if I remember right. Oops. Oh, sorry, yeah, it's all in the top level of it. So yeah, we create the contract. Here it is. We deploy the contract here. This is sending the transaction to deploy the contract. And then once that's done, we go ahead and we get the address for the contract that we've just deployed. We fetch, and then we fetch some values from this this contract. I thought we were actually sending the transaction as well. Regardless, yeah, so feel free to read through this on your own. Here we go. Yeah, this is we're making a call out to it. There is an example in here for sending a transaction, but yeah, suffice to say, I mean, the Web3.js docs will help you out quite a bit here, and also have a look at the Web3 EEA docs and the Web3 Quorum docs on the corresponding docs pages for that. Yeah, and really that's about it. So this is, again, a great way to get up and running with a simple private network on your own machine. Once everything's up and running and you have these images downloaded, you can run this without any kind of network connection. Everything's all totally self-contained. Great. Thanks.
Thank you very much, Ben. So we will keep some time for Q&A, but first, thank you for your time today. And so we will be sharing this doc with you, and on this page, you will find some useful links. So the first one is the feedback form. So it would be very much appreciated if you could fulfill it. Then we will have the link to the Quickstart that Ben has just demoed. And then you have the links to our communication channels that we are monitoring. So we have a channel on Discord to discuss everything related to Quorum. We have a channel on Rocket Chat for Besu. So that's typically where the community raises some issues or questions, technical questions they have related to the client, but not only. And then we have a Slack for GoQuorum with some public channels that you are very welcome to join if you have any questions around GoQuorum. And finally, if you want to reach out to us for any questions, you can also email us at quorum@consensys.net. And so let's move to Q&A. Grace.
Great. First of all, thank you. Everyone's asked a lot of great questions in the Q&A box, so much appreciated. We've left a few that we'll answer now. And then if you have more, of course, please go ahead and keep dropping them in. We'll take about 10 minutes of questions. So the first one is, in Quorum, is it possible to send a private transaction from a node to a private smart contract, which is not private for this particular node? The node, however, cannot access the private state. Is this an expected behavior? I'm not sure who's the right person. Is that a Madeline question? Is that maybe a Josh question?
So I think that's either a Nico or I question. So in the next release of GoQuorum and Tessera, which is coming up this month, there's going to be an enhanced privacy feature which you can flag so this behavior is no longer possible. Nico may be able to talk to the specifics more.
Yeah, so it has actually been merged today, the privacy enhancement into in GoQuorum, and that will be released next week as part of the as part of the next release of GoQuorum, and I should not say the number because it will probably be a clever. So we will see. But about this privacy enhancement, we are adding an option for private transaction named party protection that will allow that basically will disable the behavior that you just mentioned. So only nodes that have access, that actually have access to the private smart contract will be able to send transactions that might affect this private smart contract. So the behavior that you just described will be disabled by this new feature.
There's going to be documentation on this feature merged in the next day or so as well.
Yeah. So I think
sorry.
Sorry. Oh, no, if there's more to add to that last one, go ahead. I was going to go on to the next one.
Yeah, so just adding one around the privacy enhancement, there is a second one which is being added, which is PSV for private state validation, which is also a way to ensure that when you send a private transaction, that all the nodes that are executing it are actually in sync on the given state. So basically that the private smart contracts that you are using have not been diverging between the nodes because they might have been part of, they might have been different private transactions with different sets of private participants, and that might have led to the divergence of the smart contract. So there will be an option to ensure that that when you send a private transaction, it's actually all the nodes participating to it are in sync with the state of the smart contract they are using.
Great. Yeah, so for this next one, I think I can answer this. So the question is, how is running ConsenSys Quorum different from running a private Ethereum node with Ganache or Goeth nodes? So I actually used to be one of the maintainers of Ganache, so I feel qualified to answer this. The main difference is I like to think of Ganache and Goeth as RPC simulators, right? So they're actually simulating a node. They're not really running a true Ethereum node. For example, they can't peer with other nodes. So they're great tools to use for writing automated tests and things like that. But if you're trying to develop against a real blockchain network, you'll eventually need to run against a real blockchain network. Also, if you'd like to run a blockchain network in production at some point, you should probably get familiar with how to run it. So the Quickstart tool that we have is a great example of how to run a blockchain network. But yeah, so the main difference really is just that Ganache and Goeth, they're development tools. They're designed to be very focused on development. They mostly behave like a real Ethereum node, but there are some slight differences, and those differences are there kind of to aid development, aid your debugging process. But they do behave differently than a true node would behave in production. So you'll want to run against real nodes like ConsenSys Quorum.
Couldn't find the unmute button. That was a great answer. And yeah, wow, we're a maintainer of Ganache, so you're the perfect person for that. Next question is, why not keep the support for two existing clients and in a longer term have them merged? I don't see the point to keep the two live for the future, actually. I can take this one. So I think I answered originally that basically our plans for the near term and medium term are to make them interoperable. The future of the different clients will be assessed once they are interoperable, and then we're able to say, what makes sense. But in the near term, having them work together and being able to use one private transaction manager and have the permissioning setup work is the priority. But it's, and once we have those in place, we can make a better decision on the future. Next question is the private group's creation managed by a smart contract that is already deployed once I deploy a Quorum node? Is that maybe a Nico or Madeline question?
Yeah, so I'm just thinking about, so the private group creation is, I'm just trying to get my head around the question, sorry, out loud. So is the private group creation managed by a smart contract was already deployed once I deploy Quorum node? So private group creation is done, and the first time you send a private transaction, the private for participants will define the participants of the smart contract. So it's the act of sending the private transaction that creates the private transaction smart contract.
Great. No, good answer. I think we'll give everyone one more minute, maybe to submit their last questions, but are there any licenses required from ConsenSys for enterprises to start using Quorum? I can take this one. So ConsenSys Quorum is open source. Hyperledger Besu and GoQuorum are open source. You can get started and run your network on it right now. There's no payment. There's no, stop or any kind of thing you need to fill out. They're open source. Hyperledger Besu is a Hyperledger project. You can go on the Hyperledger GitHub and wiki and find it there. GoQuorum is under the GitHub, the ConsenSys GitHub repo, and essentially you could use it right now. There's no licensing or anything like that. If you did want support for for your network or for getting set up using ConsenSys Quorum, then you can also reach out to us and we'd be happy to discuss those subscription services we offer. All right, looks like we got a couple more and then we'll wrap this up. So are there any considerations to enable hybrid transactions that might change both public and private state?
So I can take that one. So not at this stage. So currently private transactions can read from the public state, but they can't update it.
Great, and then this is going to be our last one, but thank you. Do I have to deploy a smart contract to manage privacy groups and private transactions, or is it already built into a smart contract?
So there is a set of smart contracts that are part of Hyperledger Besu to do the privacy group management. So they're covered in the documentation and the way they work is covered there. But yes, basically they are already there.
Are those pre-deployed, I think is what they're asking.
Yes, they are pre-deployed.
Great, well with that, thank you everyone for your time. Here's my shameless plug one more time to please fill out the feedback form. I'll drop the link one more time. We're always looking to improve and make sure these sessions are meeting your expectations. So I'll drop it in one more time, and if you all don't mind, filling it out, that would be great. But thank you for joining, and please go ahead and get started using Quorum.